Thanks, Matt. It's great to be here in New York and see such well-dressed data scientists and engineers. Out west, folks aren't always so dapper, so thank you for putting on the nines for me today. Today, I'm going to talk about my passion for a very specific data variety, spoken business conversation. At Gridspace, we've spent several years building applications for turning speech to text, finding highlights in conversation, and giving teams a really clear picture of all their spoken business interactions. I have a fanatical belief that voice-aware systems are going to really transform the workplace. And I will tell you a little bit why, but first I want to let you in on a data-driven process I use to come up with some of the content of this talk. Here's a screenshot of my console. So using Gridspace software, I gathered and analyzed full voice audio for about 100 past data-driven talks. And I did this to sort of uncover what folks talked about, so maybe I could focus on the right things and not be too redundant. It was about 250,000 words in all, and I want to quickly show you the results before talking a little bit more about voice processing. So this is what past speakers covers. As it turns out, people talked a lot about data. They talked about data sources, and they talked about architecture and scale and all those wonderful things. But what was really interesting to me was how different people talked about data. VCs like Matt tended to talk about subjects related to business. Other folks focused on data for social good and data education. And folks in the middle nerded out about systems for processing data. I will probably be somewhere in between. Hopefully, I will be able to fuse a lot of these subjects into one talk and delight you today. What folks didn't talk about? Well, folks didn't talk very much about sales and marketing. Apparently, nobody has competitors here at Data Driven. There wasn't much talk about competition. And there wasn't much talk about machine learning, especially applied machine learning and expectations around AI. So I thought that might be a good place to start. So we're going to talk about voice data today. We're going to quickly go over the evolution of voice processing and touch on some of the outputs of this processing and the interfaces that touch humans, task-oriented interfaces. And then hopefully we'll get to close with a conversation with Matt about collaborating with machines. So people speak about 100 times more words than they write in email. And some of the most important content is in business conversation. For data scientists and engineers, a lot of this voice conversation comes with labels. From broadcasts, we have professional transcripts. From phone interactions, we have speaker identities. And from contact centers and agents that work in them, we have crowdsourced tags and business outcomes, like true business outcome data from these businesses. Yet, with all this streaming voice data and previously recorded voice data and all these labels around it, it's still very difficult for systems to make sense of it. And that's one of the reasons why we created Gridspace. But I want to quickly jump into why it's such a hard technical problem, because I think that's an interesting subject. So to explain why this is a hard technical problem, I'm going to compare and contrast a computer vision processing pipeline with an audio processing pipeline. We're going to literally process with words corn.jpg and corn.wave. With images and computer vision, the output representations from a computer vision pipeline are pretty crisp. From a satellite photo or collection of satellite photos, we can actually equate corn to pixels. We might say there's 100 corn in this pixel. The boundaries are very clear too. We can say, hey, there's the most corn in the northeast field of this farm. Ultimately, we get this pipeline that is fairly complicated, not too many lines of code. Voice processing, the situation couldn't be any different. The output representations are in natural language, human sentences and figures that were expressed by humans. The boundaries, when somebody says something in a sentence or in a conversation or in a collection of conversations, has no real connection to where those things are necessarily in reality. We have difficult signal processing challenges, denoising problems in both with satellite images or clouds, optical distortions, and same is true with audio. We have echo and background noise. But the ultimate pipelines are far more complicated with audio. That said, in the last decade, we've made tremendous progress. Huge progress on all the sort of steps in this pipeline. Transcription has gotten better. We've gotten better at natural language processing. And we've gotten more clever and creative about how to take natural language outputs and make them usable to humans. We've come a really long way from Bell Labs in the 50s, where we were recognizing single speakers, through modern systems like Gridspace that use deep neural nets for acoustic modeling, and future systems. We hope in the near future systems will use end-to-end deep neural nets to process audio and sort of clean up some of the messy code that's involved in these current pipelines today. Another really important thing to note is that all these parts are highly additive. So when we get a win in ASR, or a win in natural language processing, or a win at the HCI layer, we ultimately produce a much better experience for the user. And some of the biggest wins are coming in these areas today. To give you a little illustration of how challenging it is to use after you get these natural language outputs in software, I'm going to read a quick ridiculous sentence for you. OK, here's the ridiculous sentence. A modern ox is a couple of feet in front of the hay wall. It is cloudy. The ground is shiny grass. The huge hamburger is on the ox. An enormous gold chicken is behind the wall. This is the scene was created with some software called WordLens, and WordLens took this ridiculous natural language sentence and created an entire 3D scene. How useful this 3D scene might be to somebody at work, I'm not sure, but it's certainly creative. And I think creativity is pretty important when it comes to designing these interfaces. But I think the best interfaces are task-driven. And at Gridspace, we've really focused on crafting specific task-driven interfaces that make voice more clear. This is an interface for an application called Gridspace Memo that helps workers understand their conference calls. Here we're focused on entity extraction, understanding sort of key terms mentioned in the conversation, and emphasizing search, helping workers go back into a small collection of calls and quickly pick out a detail that they need for an upcoming meeting. Here's an interface for an application that we call Gridspace Sift. Sift focuses on classifying large collections of calls and making it easy for teams to keep track of performance in key areas, how well certain interactions in one business unit are performing, how well folks are handling inbound calls. It also is an interface that's designed to help people pick out anomalies, weird situations where something is going awry. So how do we continue to make progress in voice processing and with voice-aware systems? Well, the name of the game is to keep reality ahead of expectations. This is, we talked about it a little bit earlier. Here's a researcher speaking into a voice recognizer at Bell Labs in 1952. And the system was tuned for a single speaker. and it's outputting a number, the number that he says. Does anybody want to guess the word error rate of this system? Any guesses?
What's he get?
52.
50
and 52. That's a reasonable guess. Actually, the recognition rate of this machine was 97 to 99%. It was incredibly accurate. But it was designed for a single speaker. It was very large, used a lot of electricity, and ultimately wasn't that useful to businesses because of its specificities as one speaker. So my final point here is that we really have to embrace simple tasks in a whole way and embrace users. And part of that requires us to add value at all these layers, not just at the algorithms level or the sort of core infrastructure development level, helping Moore's law continue, but also at the HCI level. And I really think that's where some of the most exciting gains are going to be made. That's about my time. Thanks very much. That's my email address. I hope you learned a little something about voice processing today. Thanks.
Thank you. That was super interesting. So I'm just going to ask a couple of questions, and then I will open up. Andrew, you have a mic, right? Okay, 2 mics. Okay, good. So one of the recurring themes we talk about here are, once you have the data, there's plenty of things you can do with data in general. But in reality, a big part of the challenge is how to get the data, extract the data. How does the data engineering part of this work? How do you get all this sound data? For example, what you did with the YouTube content, which was awesome, by the way. How do you ingest that? How challenging is it? And how does that work in an enterprise context?
Yeah, no, that's a great question. So when we're talking about voice data, there's a few companies that control the pipes. And those companies are Cisco and Avaya. And they have a pretty large footprint in contact center and then also in unified conferencing. So these companies are working really, really hard to make content that flows through their pipe, media content, accessible to voice applications, because it makes their infrastructure more valuable. And in the process of sort of making their infrastructure more valuable to voice application providers, they're cutting out system integrators. So there is this sort of natural push to simplify integrations to get access to it. So the real sort of questions are, when this will hit a tipping point and sort of every voice interaction inside a business will be sort of easily accessible via API. And I think that's happening very quick as voice processing technology, voice applications hit baseline utility levels.
And outside of Avaya and Cisco, are you guys looking at, media content and that type of thing?
Yeah, we're not as focused on indexing media content, although it's a really interesting use case. Folks that are working on that problem, I think, are going to have lots and lots of opportunities in the future. Right now, we don't really know what's going on in most advertisers don't really know what's going on in the YouTube videos they advertise against. It's also really hard to react in real time to content people are producing. So I think there's lots of interesting opportunities, especially with real-time processing ahead.
Great. And what's your background, out of curiosity? Do you have a background in machine learning?
Yes.
I have one more tick.
My background, I'm an engineer. I did my undergrad at Stanford. I studied product design. I was sort of self-taught software engineer before I went to school, and have worked on sort of messy system problems professionally through school and then after school. So these are tools in our tool chest, but by no means silver bullets.
Very cool. Let me open up to see if there are questions, whoever you're closest to.
Chris from Community Sift. We work with gaming companies to get rid of toxic users. A lot of them ask me, what's coming down the pipe for audio? How can we solve the problem for audio? Are we close? Or?
Oh, that's a fantastic question. So by toxic users, we're talking about harassment and cyberbullying in games. Yeah. So I think there is certainly things that will help you solve those problems. The challenge is it's not always a word, it's context. So we're pretty good at detecting real words in time. We can also detect collection of words. But what constitutes harassment and what doesn't, these are messy natural language processing problems. So I think that you'll start to see more of these systems in games. But that's a great use case. Not something we're doing anything with.
Great. There was one here. Oh. Yeah.
Hi, George Davies. I'm involved in the sentiment analysis space, and this is really interesting because it seems to me there's even another dimension that you get here with things like voice intonation. Do you guys do anything with sentiment analysis and sort of intention? Words are words, but how you say them, they can mean different things.
Yep, great question. So we don't do much in the way of sentiment analysis at the signal layer. There's a handful of folks that have worked on that problem. We find it's really hard to get ground truth on how somebody's really feeling. We have outcomes. We know when somebody ceases to be a customer or hangs up a phone, but we don't really know if somebody was sad or happy. There's this messy middle ground of emotions that's hard to keep track of. So we've taken the approach that we really focus on words and try to figure out intent from words. But even that is a messy problem, and we've focused, like sort of the talk suggested, on simple tasks that we can do repeatably.
There's one here. How real time? Well, the question. How real time is this, Evan? How real time is it? The processing.
We do real time processing.
It's completely.
Yeah, it has to be.
Okay.
How much have you looked at different languages and different language groups, especially ones that do depend on intonation, Chinese, for instance?
We're focused on English, which is hard enough. English was actually harder than many romantic languages because the orthography in English, it means it's like how words get written and then said there's a better connection in romantic languages than English. But we're laser focused on English right now. I think there are tremendous opportunities for folks that are working on recognition systems for other languages, especially with the intent of giving people access to the internet that don't necessarily know how to read or use a traditional smartphone. Yep.
Here we go. One last question.
Hi, I'm Cecilia from Mattermark. How do you handle changes in a word's definition over time? Like, for example, the word unicorn didn't mean what it meant less than a year ago.
Yeah, a great question. We are ultimately sort of depending on applications that have a feedback loop where there is some sort of engagement through the application that helps us clarify words that change over time. I don't know how else to do it. Thanks.
Okay. Well.
Oh.
Are you claiming your right to a question? That's the spirit. That's good. Yeah, actually, I'll do even better. I'll give you my mic.
Two things, right? I'm running some consulting on big data, Internet of Things. Two things, I guess, coming from trading, sales, in financial world, I think this could be really good in the voice-based trading, which is still a large chunk of trading happened in financial market. Yep. And secondly, in the graph you show in the beginning, you analyze 250,000 of whatever words or something from these talks. There is clear a cluster on the left side in the middle graph.
Yep.
Can you explain it from whatever your insight?
You're talking about our nearest neighbors analysis of, yeah, the nearest neighbors. Yeah, I mean, the long story short on the analysis we did on the data-driven talks is the talks are relatively similar. People use a lot of similar words. What we found was that certain groups tended to have topics more related to business or education or technical terms. And those connections, although we didn't do the sort of secondary analysis where we're actually connecting what companies do back to their talks, just from a personal perspective, it seems to be related, but there's still more work to be done there.
But there's a clear cluster.
Yeah.
If you can show the graph, clear cluster on the left middle
Yep.
edge of the graph.
Yes. I didn't label one of the clusters. You got me. Yeah.
People actually pay attention.
Yeah, thank you, but I appreciate your question. But yes, good job.
That's
Real data scientist.
all right, wonderful. That's all the
very
time we
much.
have. Thank you very much. You'll be here after this, right? So
Yeah.
if people want to
Yeah.